Ever wondered why granulation is deemed essential in various industries, particularly in the pharmaceutical sector? Granulation, in its simplest form, is the process of transforming fine powders into granules. This process is not just a mundane exercise in the world of manufacturing, but it holds the key to improving product quality and efficiency across a host of industries, and none more so than in the realm of pharmaceuticals. Now, why is this so important? Well, granulation enhances the flow of powder, reduces segregation, and curtails dust. It also decreases toxicity and augments the density of the material. These improvements lead to better handling, precise dosage, and enhanced drug absorption in the body. In essence, it's the unsung hero of the manufacturing process, playing a pivotal role in ensuring that the pills and capsules we take daily are safe, effective, and easily digestible. In the forthcoming scenes, we will delve deeper into the fascinating processes of wet and dry granulation. First off, let's explore the wet granulation process, a technique predominantly used in the pharmaceutical industry. This method is a favorite for its ability to enhance the flow and compressibility of pharmaceutical powders, thereby improving their manufacturability. The wet granulation process starts with the preparation of a raw material mixture. This mixture typically consists of the active pharmaceutical ingredient and various excipients, which are substances that aid in the processing and stabilization of the active ingredient. The mixture is carefully prepared to ensure uniformity, which is crucial for the consistent efficacy of the final product. Next, we introduce a granulating liquid into the mixture. This could be water, an organic solvent, or a binder solution, depending on the characteristics of the raw materials. The liquid serves to agglomerate the fine particles, creating a wet mass. The choice of granulating liquid and the amount used are critical factors that can significantly affect the properties of the granules and, ultimately, the quality of the final product. Once the wet mass is formed, it's then subjected to sieving. The aim here is to break down the mass into granules of a specific size. The granules are then dried to remove the residual moisture. This drying process can be performed using various techniques, such as tray drying, fluid bed drying, or spray drying. After drying, the granules undergo a final sieving stage. This step ensures that only granules of the desired size are selected, while the oversized or undersized granules are separated for reprocessing or disposal. The final product is a batch of granules with improved flow and compressibility, ready for the next stage in the pharmaceutical production process. That's a wrap on the wet granulation process. Now let's shift our focus to the dry granulation method. Now let's unravel the dry granulation method, another vital process in the industrial world. Our journey into the world of granulation takes us next to the dry granulation process. This method is particularly suited for materials that are heat-sensitive or do not respond well to the presence of moisture, making it a valuable tool in the pharmaceutical industry. The process begins with the careful preparation of a raw material mixture. This mixture is made up of the drug substance and various excipients, which are non-medicinal components used to aid in the manufacturing and consumption of the medicine. This could include fillers, binders, disintegrants, or lubricants, all carefully chosen for their specific properties. Once the raw material mixture is ready, the focus turns to compaction. This is achieved through the use of either a roller compactor or a slugging tool. The roller compactor applies a high-pressure force to the mixture, compacting it into a solid mass, while the slugging tool uses a large tablet press to create slugs or large tablets. The choice of compaction method depends on the specific properties of the raw material mixture and the desired end product. After compaction, the solid mass or slugs are then subjected to a milling or grinding stage. This is where the granules are born. The milling or grinding breaks down the compacted mass into granules of the desired size. This size is carefully controlled to ensure the granules are uniform, promoting even distribution of the drug substance and improving the flow and compactability of the granules. The dry granulation process is a delicate balance of preparation, compaction, and milling, each stage carefully controlled to produce the perfect granule. It's a testament to the precision and ingenuity of pharmaceutical manufacturing. With this, we conclude our discussion on the dry granulation process. This method, along with wet granulation, forms the cornerstone of granule production in the pharmaceutical industry, turning raw materials into the medicines that improve our health and well-being. Beyond the basic wet and dry granulation methods, there are also some advanced granulation techniques. These techniques delve deeper into the science of granulation, employing advanced technologies and methods to achieve more precise and controlled results. First, let's discuss steam granulation. This technique uses steam as a binding agent instead of a liquid solution. The steam permeates the powder mixture, leading to granule formation. Steam granulation offers several advantages, such as reducing the amount of binder needed and shortening the drying time. It's a technique that's particularly useful when dealing with heat-sensitive materials. Next, we have melt granulation. This is a technique where a meltable binder is added to the powder mix. The heat melts the binder, causing the powders to aggregate and form granules. Melt granulation is an efficient method that reduces the need for solvents and drying processes. It's an ideal option when the goal is to create granules with a uniform size and high density. Lastly, there's the fluidized bed granulation technique. This method involves the suspension of particles in a stream of air, creating a fluid-like state. The binder solution is then sprayed onto the suspended particles, causing them to coalesce into granules. Fluidized bed granulation allows for excellent control over granule size and density, and it's often used to produce granules with specific properties. Each of these advanced granulation techniques offers its own set of benefits. Steam granulation is efficient and excellent for heat-sensitive materials. Melt granulation eliminates the need for solvents and drying, and fluidized bed granulation offers great control over granule size and density. These techniques aren't just scientific curiosities. They're practical tools that are being used in various industries, from pharmaceuticals to food processing, to create granules that meet specific requirements. Whether it's creating granules that dissolve quickly in the body, or granules that add a certain texture to food products, these advanced techniques are reshaping the world of granulation. These advanced techniques provide more options to industries in creating granules that suit their specific requirements. Knowing how to make granules is one thing, but how do we assess their quality? When it comes to granules, the devil is in the details. The quality of granules is evaluated through a variety of measures, each focusing on a different characteristic. Firstly, we have size distribution. This is the measurement of the diameters of individual granules in a batch. The size of the granules can have a significant impact on the performance of the final product. For instance, in the pharmaceutical industry, size distribution can influence the drug dissolution rate, which in turn affects the drug's effectiveness. Then there's density. Density involves the mass of the granules in relation to their volume. High-density granules tend to have better flow properties and are less prone to segregation. However, they can be more difficult to compress due to their reduced porosity. Flowability is another crucial characteristic. It's the ability of the granules to move and settle, which is critical during the manufacturing process. Good flowability ensures that the granules can be evenly distributed within a tablet or capsule, resulting in a consistent dosage. Next in line is compressibility. This is the ability of the granules to deform under pressure without breaking. High compressibility is desirable as it allows the granules to form a compact mass, which is crucial in tablet formation. These characteristics are not isolated. They interact and influence each other. For instance, granules with a narrow size distribution often exhibit better flowability and compressibility. Similarly, high-density granules can demonstrate improved flowability but reduced compressibility. Therefore, it's not about achieving the best in each characteristic. Rather, it's about finding the right balance that suits the specific application. That's where the art of granulation comes into play. Understanding these characteristics is crucial for ensuring the quality of the final product. And remember, granulation is not just a process, it's a science and an art that requires a deep understanding and meticulous attention to detail. Let's recap what we've learned about granulation. We've delved into the fascinating world of granulation, exploring its indispensable role in the pharmaceutical industry. We've understood that wet granulation, with its use of a liquid binder, leads to strong and dense granules, while dry granulation, involving compression without a liquid, creates granules with a more porous structure. We've also journeyed through advanced granulation techniques, highlighting how modern methods have revolutionized the granulation process, making it more efficient and precise. Finally, we've discussed the characterization and evaluation of granules, emphasizing the importance of assessing parameters like size, shape, and density to ensure the quality of the final product. As we've seen, granulation is a complex yet crucial process, shaping the world of medicine as we know it. That's all for today's enlightening journey through the world of granulation. Subscribe for more because you won't find me later.